the last thing we're going to talk about is the rational root theorem. What the rational root theorem does is allow us to find all the possible real roots of a, all the rational roots of a polynomial. Okay, so what you're going to do is divide the constant term and the leading coefficient you're going to take both the positive and negative values of each result, and you're going to test all of those results by using the remainder theorem. Okay, so here, for example, my leading coefficient is 3. My constant is 60. So what you have to do is take every factor of 60. So 1, 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 no, 8 no, 9 no, 10 is 6. So that's done. And once you do 60, you need to do 3, which is just 1 and 3. From here, you take all these possibilities and you put them over each other. So plus or minus 3 over 1, 3 over 60, 3 over 2, 3 over 30, 3 over 3, 3 over 20, 3 over 4, 3 over 15, 3 over 5, 3 over 12, 3 over 6, and 3 over 10. And again, these are both positive and negative. From there, you'll do the same thing except the 3 that's up top everywhere is going to become a 1. All right, so all of these are the possibilities, and then what you can do is test them by using a remainder theorem. And remember to use the remainder theorem. What you do is you type the top equation in, so f of x all right. And then you can do a couple of things, right? You can click on all of these, and from here, you know a rational root is something that's a pretty number, okay? So -4 All right, and I actually messed up on this one because we're going to use the 1, the 60, the 2, the 30, the 3, the 20, the 40, 15, all of those. So I did absolutely all of this backwards. I didn't realize it until right then. All right, because so it's your constant over your leading coefficient. All right, so 1 over 1, 1 over 3, 60 over 1, 60 over 3, and then so on and so forth. And then we do this enough, and again, we get back to -4 and +3. So if I go f -4, I get 0. And then f of 3, I also get 0. So that is how you use the rational root theorem. Now, the entire purpose behind rational root theorem is to help us to be able to find the remaining zeros, which are either going to be irrational or imaginary. So every polynomial we work on in Math 3 can be reduced to a quadratic at worst case scenario after using rational root theorem. And so rational root theorem honestly has no use since you're able to use a graphing calculator. But if you were not able to use a graphing calculator, rational root theorem would be extremely important, because we would first go rational root to remainder to check which ones were really rational roots. After we did that, we would use the fundamental theorem of algebra to figure out how many real or imaginary roots were still left. So it's kind of cool to see how all of this ties together.